Introduction to Deformation of Solids. The Pennant Bridge is one of the longest bridges in the world. Thick cables are used to support the middle span of the bridge so that ships can sail below the bridge. Each day, thousands of vehicles use the bridge. During peak hours, the bridge is laden with the weight of the vehicles. The cables are stretched. What happens to the cables when there is no load on the bridge? The cables regain their individual original length. The property of the cables that enables them to regain their original length is known as elasticity. The cables and beams of the bridge undergo deformations. Stress and strain are experienced by the various parts of the bridge structure. In this lesson, you will be able to define stress and strain for a stretched wire, define Young's modulus, and learn to determine the Young's modulus of the material of a wire. Click Jump 1 and observe how the elastic cord tied to his leg extends. If the person were to jump with a thicker elastic cord of the same length tied to his leg, would you expect the extension to be greater or smaller? Now, click Jump 2 and compare the extensions. Click Replay if necessary. The extension of which cord is greater? Answer: the extension of the thinner cord is greater. When a longitudinal force stretches an elastic cord, the extension is inversely proportional to the cross-sectional area of the cord. The longitudinal force per unit cross-sectional area is known as stress. How does the extension of an elastic cord depend on the original length? P and Q are two identical elastic cords. The length of Q is twice that of P. Click and drag each of the weights W and hang it from the lower end of each cord. Compare the extensions of the cords. Answer: extension of Q is twice that of P. The ratio of the extension to the original length is known as strain. Click on the hand to view the definition for strain. The length of the section OP of a thin wire is 200.0 centimeters. Increase the longitudinal force stretching the wire in steps of 10 newtons by dragging the loads onto the pan. What is the extension? Calculate the strain. Summary: property of a material to regain its original dimensions after a deforming stress has been removed is known as elasticity. Stress equals longitudinal force over cross-sectional area. Strain equals extension over original length. Unit for stress is Newton per meter square. Strain is a dimensionless physical quantity and has no unit. How does the extension of a wire vary with increasing force. Click on the load one at a time to increase the force stretching the wire. Observe that the force extension graph is been traced simultaneously. What is the relationship between extension and force? Answer: the extension is directly proportional to the force. The relationship between extension and force is given by Hooke's law. Summary: Hooke's law states, within the elastic limit, the extension of a wire is directly proportional to the force. Force F equals K times E, where K is the force constant and E is the extension. Young's modulus. Wires of different lengths, cross-sectional areas, and made of different materials would have different values of force constant. All wires of the same material, irrespective of their lengths and cross-sectional areas, have the same Young's modulus. Click the hand to derive an expression for Young's modulus. What is the relationship between the force constant K of a wire and the Young's modulus E of its material? Drag and drop the appropriate quantities for stress and strain in the given boxes. Click on Young's modulus, force, Hooke's law, and relationship to continue the derivation. The table shows the values for the Young's modulus for 4 different metals: tungsten, steel, copper, and aluminium. Click and drag to hang each of the loads W from the lower end of each wire. Compare the extensions of the wires. Guess the material of each wire. Drag the name of the material from the table and drop it in the appropriate box. Click Answer to check your guess. Steel cables of cross-sectional area 2.50 times 10 to the power -4 meters square are used in a suspension bridge. The original length of one of the cables is 5.00 meters and support a load of 3.60 times 10 to the power 5 newtons. What is the stress in the cable and its extension? Click Solution. Summary: Young's modulus equals stress over strain. Unit of Young's modulus is Newton per meter square. Force constant of wire K equals E times A over L, where E is the Young's modulus, A is the cross-sectional area, and L is the original length. Determination of Young's modulus of the material of a wire. The Searles apparatus used to determine the Young's modulus of a wire has several features. Try to give the reason for each of the features shown. Vernier scale, long thin wire, two identical wires. Then click on each feature to check your answer. Click on a load to increase the longitudinal force on the wire in steps of 5 newtons. Click Graph to observe the graph of extension against load being plotted. Click on each step to observe how the Young's modulus of the material of the wire can be deduced from the data obtained in the experiment. The table shows the data for two pieces of wires, P and Q. Click and drag loads of the same weight to hang from the lower end of each wire. Observe the extension of each wire. Key in your answers for the corresponding value of extension, stress, strain, and Young's modulus for wire Q. Then click Check to check your answers. Summary. Searles apparatus is used in the experimental determination of Young's modulus of the material of a wire. Young's modulus equals 1 over gradient of extension force graph times L over A.